Hey everybody, Mr. Gibson here. So for 1.4 in units, so this is the fourth section in Unit 1. Last one, so there isn't a 1.5. This is going to be it finally. So what this portion of the unit, we're still learning about the structure of the atom, but every atom's unique structure, specifically when it comes to its electrons, means that when it releases energy, each atom gives off a specific color. And we call this its atomic emission spectrum. Now, that's a weird term, and there's a little bit of science that goes into that you're going to learn through the next couple of explore activities. But when we're talking about light in different colors, what we're really talking about is waves, light waves. Light is made of photons, but they also behave like waves. It's kind of complicated how they're both particles and waves, so I'm not going to get into it. But we need to start thinking them as waves. And waves have certain properties like frequency and wavelength. Okay, you may have heard those words before. You may have never heard those words before. So what I'm going to do with this specific assignment, Explore 1.4a, is you're going to learn some of the characteristics of waves, and hopefully that will help you better understand the different characteristics of light waves that some elements give off. Okay, so here's what you're going to do. It says to understand how elements give off certain colors of light, it is important to first understand how waves work, since light is made of waves, and we call this electromagnetic radiation. That's just a very fancy way of saying light waves, okay, waves of light. So first you're going to open this Google slide, okay? This is super cool and you guys get to keep it. It is yours. This is the entire electromagnetic spectrum, meaning these are all the different kinds of light in the known universe, okay? Going from long radio waves, which those waves are about the size of buildings. So those are like your AM and your FM, or these are long radio waves. And then we get to your AM and FM, which is what your radio picks up in the car. Those are actually not sound waves, it's light waves transmitting that information. And then we have microwaves, which we use to heat up our food. You guys can go home and probably turn on your microwave. You can't see that, but you're making this kind of light. It's a frequency of light. Okay, then we have infrared light radiation. Okay, and then this tiny little band here, it happens to be the specific kinds of light that we can see with our eyeballs. So we, up till now, we've thought of light as just something that we can see, or something that helps us see the things around us, when actually there are way more different kinds of light that we can't see. Our eyes have just evolved to be able to see frequencies or wavelengths of light within the certain range. So at a wavelength of 750 nanometers, we might see dark red. At 620, we might see orange. At 590, yellow. All the way down to wavelengths of 380 nanometers, we see the color violet. And so when we pick up light, that the waves are at certain wavelengths, meaning literally the lengths of the waves, or the length between the top of one wave and the top of the next wave, are within these specific sizes in nanometers. Our brain interprets that kind of light as these different colors, going from red all the way to violet. It's Roy G. Biv, right? Just like the colors of the rainbow. Okay. Now, if we have light that has a low enough wavelength that it's out of our visible spectrum, then we get into ultraviolet light. And you may have heard of that, like it's given off by the sun, may cause skin cancer. Then we have X-rays. And then we have, this is the Greek letter for gamma. We have gamma rays. And those are the most energetic, meaning they have the lowest wavelength and the highest frequency. Frequency meaning that they happen over and over and over really fast. It's really frequent, okay? And these are therefore very dangerous. This can damage your DNA and cause some mutations. So what I want you to do is just have this, because it's really important, because when we look at different elements, when we say they give off certain colors, really what we mean is they give off different wavelengths of light. So if like sodium, for example, probably gives off a color somewhere in the range of 590 nanometers as its wavelength, so it appears like yellowish orange to us. Okay, strontium is in this range for its wavelength, so that means it gives off a reddish color to us. All right, so I want you to have this and put it in your notebook. It's going to be super useful. Now let's get back to the rest of the assignment. For the rest of this to make sense, I want you to understand the properties of waves. And if I were to just say, hey, here's what frequency is, here's what wavelength is, here's all the information, memorize it, I feel like that would be as beneficial as you doing a little bit of exploration on your own. So that's what this is designed to do. So you're going to click on this link. It's going to pull up a simulation, and it's going to show us waves. You're just going to make waves with a string of beads and a wrench and a clamp over here. So all you're going to do is switch this to oscillate, and it will move, and it'll give you specific instructions. Okay, and you want to make sure it's always clicked to fixed end. You don't want to click either of these. Okay, so what this is going to do is you're going to use that simulation to answer the questions in this Google Doc. Now it looks kind of long. That's just because there's a lot of instructions. It wants you to be, it's very specific about the instructions. So make sure you follow those or none of this will work. And I've put in bold all the questions you should answer. So there's technically only 18. Okay, so not too terribly bad. And you can just type those right in there. You'll get your own copy when you click on it. And then once you're done with this, you'll turn it in. Now some of these towards the end, have you do a little bit of simple math. It gives you an equation, velocity, so the speed of light equals frequency times wavelength, and it gives you the frequency and gives you the wavelength. It just wants you to multiply those to give velocity, okay? Super simple, and you should be able to find a calculator online if you don't have one that will do that for you. You can just type it in. Some of those got kind of complicated towards the end, so I took those out just in case some of you didn't have a graphing calculator, okay? So make sure to put this in your notebook, open the simulation, open the Google Docs, answer the questions using the simulation, and turn it in, and you'll be amazed about how much you're going to learn about light, something that's around you all the time and you may not have known very much about. Okay? If you guys need any help, let me know. Good luck.